right, ladies and gentlemen, we're going to take a look at our last lesson here in Chapter 6, and this is our reasoning about these special quadrilaterals. So we've introduced you to quite a few special quadrilaterals. We've looked at the parallelogram, we've looked at the rhombus and rectangle and square, and then we've looked at the trapezoid. And so now what we want to be able to do is to look through a limited basis of information and identify which special quadrilateral is. We want to give it the best name possible, but we need to look at what characteristics we have. So we're going to talk through that. The first thing I give you is this very nice flow chart of what our quadrilaterals could be. Remember, a quadrilateral just has to have 4 sides. All right, so there's a lot of shapes that can make up a quadrilateral. Some of those quadrilaterals are going to be parallelograms. All right, remember parallelograms have opposite sides being parallel, and I should say both pairs. All right, and from those parallelograms, we can then have rhombuses that have 4 congruent sides. Or we can have rectangles that have 4 congruent angles. And so once we identify that we have opposite sides parallel, we then look a little bit farther. Do we have equal angles? Do we have equal sides? Once we decide one of those 2 things, we then can look and see, do we have a square? And what happens is if we have both of those things, if we have 4 congruent angles, if we have 4 congruent sides, what you can see is they come together, and this is a square. This is 4 congruent sides and 4 right angles. All right, so we're going to go through that. The other special type of quadrilateral we have is a trapezoid. And notice there's no connection, no arrows pointing at both of these. So it's kind of like there's a great divide. Because a trapezoid only has 1 pair of parallel sides. And then from that, we can decide that we have an isosceles trapezoid, which has the legs, I guess we could say congruent legs. So the non-parallel sides are going to be congruent to each other. All right, this is a nice chart to have out. Keep open. I would guess it's in your textbook, so as you're working through things, have either your note-taking guide or have that page marked in your book. All right, so let's take a look. We want to complete each statement. So what we know about these is we know that a square is always a rectangle, a rhombus, a parallelogram, and a quadrilateral. And so what you're going to do is, part of what you'll do is give the best name possible. Name everything that fits. And so once you kind of work your way down, yes, I have opposite sides that are parallel. Then I say, yes, I have 4 congruent angles and I have 4 congruent sides, so I call it a square. What we have to remember is that because the square was yes in all of these previous categories, we have to name all of them. So once we identify a square, we also go back and name it as being a rectangle, a rhombus, a parallelogram, and then just a quadrilateral because it had 4 sides. So the square is what I call the most special one, but we also have to remember that along with that being the most special, it also has the most names that we have to pick up. So if we look at a rectangle, if we look at where we're at with a rectangle goes up and is always a parallelogram. And then obviously because it has 4 sides, we also say that it's a quadrilateral. A rhombus, if we take a look at the rhombus, we go back up, it's always a parallelogram, because that's where it came from, because it's 4 congruent sides or also opposite sides parallel. And it goes back up because it has 4 sides. It's a quadrilateral. So once you identify something as a rhombus, you have to work backwards and name each of those categories. Sorry, guys. A parallelogram, so if we start at parallelogram and we go backwards, the only thing we can say about a parallelogram is that it is always a quadrilateral. That's all we can say. So now if we take a look at the other side of our chart, an isosceles trapezoid is always a trapezoid. And a quadrilateral. So everything that we identify is always going to be able to work its way back up to this quadrilateral name. And then a trapezoid works back up. It's just always a quadrilateral. So do you see why this chart is so important? Because I can go through, identify what I have, and then remember to work my way back up through all of those names. All right, so let's take a look at what we're going to do here. We're going to use the properties of quadrilaterals. So it says, determine whether the quadrilateral, we have A, B, C, D, is a parallelogram, trapezoid, rectangle, rhombus, or square. And so we look at the information that's given, and hopefully what you noticed is that CE is congruent to EA. So this diagonal has been bisected because each side of that intersection is equal. And DE is congruent to EB. So both the diagonals bisect each other. So I think that's what they want us to put in there. So diagonals bisect each other. All right. So going back to the theorems that we had, we know that this 4-sided figure is a parallelogram. So it cannot be a trapezoid. So we can cross it off. We've circled parallelogram. Now we have to decide, is it a rectangle or a rhombus? Because it does not tell us anything about sides or angles. There's no information about those. I cannot guess that it's a rectangle because I don't know anything about the 4 angle measurements. I don't know anything about the 4 sides, so I have to cross out rhombus, which means square is automatically eliminated. So the best I can say for this is parallelogram. So notice I'm looking to see what I have, and then I look for more. I look for side information. I look for angle information. So now what we're going to do is try and identify a rhombus. So are you given enough information in the diagram to conclude that ABC is a square? Explain your reasoning. So when I look, I notice I have 4 congruent sides. So it shows that all 4 sides are congruent. So I know that it's a rhombus. That's what we know about a rhombus, is 4 congruent sides. It does not give you any information about angle measures, so because I don't know anything about that, I cannot conclude it is a square. So are you getting information to conclude it's a square? I would say no. It is a rhombus. And then we would say parallelogram. All right, and then they all tell you that it's a quadrilateral, so we wouldn't necessarily need to name quadrilateral. All right, so let's look at it. Are you given enough information to conclude that the figure is the given type of special quadrilateral? Explain your reasoning. So when I look at this, I have a square. Is it a square? Well, I have 4 right angles. Beautiful. So I have 4 congruent angles. So if we go back and look at the chart from the very beginning, a square had 4 congruent sides and 4 right angles. Unfortunately, if we look at this picture, there's nothing about the sides. So can I conclude it's a square? No. Because there is no information about the sides. All right, what you're going to do now is number 2, determine if this is a rhombus, and we will check in class. All right. Example 3, now we want to take a look at the other side of our quadrilateral, those trapezoids. And so we want to know, is there enough information to conclude that EFGH is an isosceles trapezoid? Explain your reasoning. So first we have to show that it's a trapezoid. And so we look, we do see that angle E and angle F are supplements, and that was one of our definitions. They are supplementary. All right, so if they're supplementary, we know that FG and EH are parallel. All right, so we know it has at least one pair of parallel sides. We need to show that it does not have a second pair, so in other words, that it's not a parallelogram. All right, we're trying to avoid being a parallelogram. So opposite angles here are not congruent. F is not congruent to H, E is not congruent to G. So because they are not congruent, those opposite angles, it cannot be a parallelogram. So because there's just this one set of parallel sides, EH and FG, we know that it's a trapezoid. Now what we want to show is that it's isosceles. And so what if we remember about isosceles trapezoids is that the base angles are congruent. So if I look, the angles that are consecutive along the parallel sides, 120 and 120, 60 and 60. So we know that base angles here are congruent. So it is an isosceles trapezoid. So what we have here, guys, these base angles being congruent, these angles being supplementary, all right, that's what you're going to use as your reasoning for tonight's assignment. All right, our last thing is this follow-up. And what it says to describe one way to show that a quadrilateral is a given special type of quadrilateral. We're going to do this together in class. Because I want us to spend some time talking about this as a group. And so if you want to start making some notes, start thinking of things, you can. Do it in pencil so that you can erase, or write small enough so that you can add some room for what we decide is the best way of identifying these special types of quadrilaterals. All right, this wraps it up for lesson 6.6. We'll see you tomorrow.